One-step inequalities using multiplication and division. When solving inequalities with multiplication and division, we're still going to use inverse operations. Remember, the inverse of addition is subtraction, and the inverse of subtraction is addition, and the inverse of multiplication is division, the inverse of division is multiplication. An inverse basically means opposite. These operations are going to undo each other. When you multiply or divide by a negative number on both sides, the inequality sign is going to flip. Notice that it's only talking about when you are multiplying or dividing by negative number on both sides of the inequality sign. So if in your inverse operations you need to multiply both sides by a negative number, only your sign is going to flip, which means if it was less than, it's going to be greater than. If it was greater than, then it's going to be less than. Okay? We've talked about flipping with everything when we wanted our variable to be on the left side to graph, but that's not what this is talking about. Whatever's on each side of the inequality sign stays there, only the sign flips when you multiply or divide both sides by a negative. So the question is, what do you do when you multiply or divide both sides by a positive number? And the answer is nothing, okay? The sign is going to stay the same. The inequality sign is going to stay the same when you multiply or divide by a positive number. It's when you multiply or divide both sides by a negative number that it flips. Some examples of one-step inequalities with multiplication and division. The first example is x divided by 3 is greater than 4. I need to do the inverse or the opposite of dividing by 3. The opposite of dividing by 3 is multiplying by 3, and whatever you do to one side, you have to do to the other side of your inequality. Notice in the red is what I'm doing to both sides. In this case, I'm multiplying both sides by a positive number, so my inequality sign doesn't have to flip. It's going to stay the same. On the left side, my 3's are going to cancel out, so I'm left with x is greater than 4 times 3 is 12. I'm not going to do examples of graphing these inequalities because I have the past 2 days where graphing inequalities and with the addition and subtraction inequalities, but you could graph this on a number line just like we have before. The next example, we have 36 is less than or equal to 3x. We always look and ask ourselves what's happening to our variable x. In this case, our variable is being multiplied by 3. The opposite of multiplying your variable by 3 is dividing by 3. Whatever you do to one side of your inequality, you have to do to the other. Again, we're looking at the red dividing by 3. I'm dividing both sides of the inequality by a positive 3, so my sign does not need to flip. It's going to stay the same. 36 divided by 3 is 12, is less than, my 3's cancel out and leave me with x. So my final answer is 12 is less than or equal to x. The next example, we have d divided by negative 2 is less than 3. When you are dividing d by a negative 2, the inverse or the opposite of that would be multiplying by a negative 2. Something should be going off. Oh my goodness, what are we doing? We're multiplying both sides of this inequality by a negative number. In this case, it's negative 2. When we do that, my negative 2's are going to cancel out and leave me with a positive d. But for an inequality, when I multiply or divide both sides by a negative number, I have to flip the sign. So instead of having d is less than, in my answer, I'm going to have d is greater than, and a positive 3 times a negative 2 is a negative 6. This is the first example where we have multiplied both sides by a negative number. The next example we are given, we have negative 0.8r is greater than 24. Always ask yourself what's happening to your variable. In this case, our variable is r. Right now, our variable is being multiplied by 0.8, a negative 0.8. The opposite of multiplying by a negative 0.8 is dividing by a negative 0.8. Again, in this case, I am dividing both sides of this inequality by a negative. When I do that, my inequality sign has to flip. R and whatever I get, 24 divided by a negative 0.8, are going to say the same side of the inequality. It's just the inequality that flips. So in this case, my final answer would be R is less than, and 24 divided by negative 0.8 is 30. The next example, I have 4 is less than y divided by 6. In order to solve for y, I need to get rid of it being divided by 6. In order to get rid of dividing by 6, I need to do the inverse, which is to multiply by 6 on both sides. In this case, notice what I am doing to both sides is multiplying by 6, so my sign is not going to flip. Now you might say, but look at the negative 4. When the negative is already there in the given inequality, that's not going to flip our sign. It has to be what we are doing using our inverse operations. In this case, I'm not multiplying both sides by a negative. I am multiplying both sides by a positive 6. So my sign is going to stay the same. A 6 times a negative 4 is a negative 24 is less than y. Now, once you get to this point, if you wanted to graph it, you can still do the same thing that we've done before, which is to flip everything now, and you could say that y is greater than negative 24 if you needed to graph this inequality. The next example, we have 24 is greater than or equal to negative 6x. If you look at what's happening to our variable, we are multiplying x times a negative 6. The opposite of multiplying by a negative 6 is dividing by a negative 6. Notice both sides are being divided by a negative number. When both sides are being divided by a negative number, I have to flip the inequality sign. A positive 24 divided by a negative 6 is going to give you a negative 4. I need to flip the sign, so negative 4 is less than or equal to x. The next example, we have 4y is greater than or equal to negative 20. I need to get rid of the 4 that is being multiplied by y. To get rid of the 4, I have to divide by 4 on both sides. When you divide by a positive 4 on both sides, nothing happens to your sign. Your 4's are going to cancel out, so you're left with y is greater than or equal to negative 20 divided by 4 is negative 5. The next example, we have y divided by negative 12 is less than or equal to negative 2. Notice my variable y is being divided by negative 12. The inverse of dividing by negative 12 is to multiply by negative 12 on both sides. Because I am multiplying by a negative on both sides, my sign has to flip. When I flip my sign, my negative 12's are going to cancel out, so I'm left with y is greater than or equal to negative 2 times negative 12 is positive 24. The assignment for today is on page 194. It's numbers 2 through 22 even and numbers 30 through 32 all.